All right, we are going to go over kind of how the oscillator and what I think makes it the easiest to learn how the oscillator works. And usually I do a drawing for any type of student or orientee that I would have. So we're gonna start with this. So we're gonna say these two lines. This would be your ET tube, all right? These are the walls of your ET tube. And how the oscillator actually works is small waveforms pushing in oxygen and taking away carbon dioxide. So you're going to have a waveform. So as the oscillator works, it's using small frequency or small breaths being taken to the baby, but it's also exchanging and coming back out at the same rate. So how I usually describe this is these waves that go up and down are either going to hold oxygen or they're going to hold CO2. So we're going to say within these waves, we're going to say this is oxygen. So this would be your oxygen being delivered. And on the opposite side, we are going to say that this is CO2 being taken out of the baby. So how you manipulate this wave is going to be how you manipulate CO2 and oxygenation. Anytime that you increase this wave, as in making it taller or you're going to make it wider, what I say is you're either going to capture more CO2 or you're going to deliver some more oxygen. So we'll take this wave for example. So anytime, I'm just going to draw this. So this wave itself, anytime that you make this wave taller, all right, and this would be called, the top would be your amplitude. So anytime that you're extending that top of your wave, of course you're going to capture more CO2. Anytime that you would extend or make that wave wider, you're going to capture more CO2. It's like you're taking a bucket and you're filling it with water. Anytime the bucket's bigger, either wider or taller, you're going to capture more CO2 to bring out of the bucket. So this wide part would actually be your hertz. And the way that we look at that is, so we're going to say a hertz of 14, which would become that, and then we're going to say the hertz of 10, which we got to say the hertz of 10 is going to be slower, and you're not going to give as many breaths. So what you're going to do is the distance between the waves are actually going to be a little longer. So if you can see in here, these waves here, this one's wider, so you're going to actually take more CO2 out. These waves are more narrow, so you're going to take less CO2 out. So the high hertz number, of course, more frequency, faster, more waves got to fit into a more compact area, like your ET tube. Of course, it's going to be narrow. wider, you're giving bigger breaths, you're taking more CO2 out, and it's less breaths within the compact, or less waves within the compact compartment here, which would be your ET tube as well. So for your amplitude as well, anytime that you would increase your amplitude, say this is an amplitude of 20, which would be the tip of your wave, all right? This would be an amplitude of 24. You're extending that wave, you're capturing more CO2. If that number's lower, you're shortening the wave and you're not capturing as much CO2. That's pretty much it.
Thank you, Travis.